Welcome to Chapter 10, Introduction to Simple Experiments. This is the first of two parts. As I mentioned also for Chapter 8, the length of the lecture for each of those chapters is such that the technological systems of the university can't handle it being long enough to handle it in a single lecture. So when we talk about experiments, we're talking about what we might want to describe as the preferred method for research because we can create high internal validity and therefore infer cause. And cause is our goal. If we don't understand what causes what, we really aren't doing our best science. It's all well and good to describe the nature of what we see in the world and to be able to describe some relationships amongst things. But we are always better off if we are able to establish that we know one factor causes another factor. And that's our goal. That's what we try to do in all sciences, and in psychology is no different. It can be difficult, however, to do experiments because it's not always practical, it's not always ethical to do the manipulations that we might have to do or to do the random assignment conditions that we would like to do. That said, is what we try to do. What we need to do is the following. We need to create two or more conditions by some manipulation of a situation or stimuli. We need to randomly assign people to the conditions. And then we need to have some kind of measurable outcome that we expect to have change occur based upon the change in conditions. There are two types of variables, and we are trying to evaluate the relationship between them. Independent variables are those that are associated with the manipulation, the conditions in the study, and dependent variables are those that are associated with the outcome. They're what we're measuring with an expectation that they're going to change based upon the manipulations that have occurred with the independent variable. Independent variables, as I said, is what we've manipulated. And it has usually an overarching name that captures the thing that's being varied from one condition to next. The individual conditions are called the levels of the independent variable. The individual conditions are the levels. This is very important that we distinguish between levels and the variable itself. I assure you, this is something I test on. The independent variable has at least two levels. Often one of the levels of the independent variable is a control group or a comparison group. It represents the usual condition compared to the manipulated condition. That is by usual condition we mean, well, how do people act normally without any kind of unusual stressor or intervention or other action that is occurring to them? The manipulated condition, sometimes called experimental condition, it's thought of as being compared to the control or comparison condition. It is what we want to see if we can have an effect on by changing things, by increasing anxiety, decreasing anxiety, increasing temperature, decreasing temperature, increasing the level of self-focus, decreasing the level of self-focus, on and on and on, all the various things that we can manipulate in people. Other times it's not so clear that there is or should be a control, placebo, or comparison condition that represents a usual situation. It's not always the case that that's just obvious that one of those kinds of things actually exists. Both conditions, therefore, can be manipulations that are away from some unmanipulated or so-called usual condition, even though it doesn't make much sense. That doesn't remove the concept that the study is an experiment, because the essential features of random assignment and elimination of confounding variables is still in place. Let's imagine a few examples. For instance, let's imagine we have a study where we want to see how people behave at a stop sign when there's a police officer present or not. Now, you may or may not know, but there's a name for the line that is on the road at a stop sign or a stoplight if there's not a crosswalk mark there, and that is called the balk line. And you are supposed to stop with your wheels behind the balk line. Better said, probably the front of the car, but you're supposed to stop behind the balk line. And we know that people vary on this. Some people stop right on the balk line, some cross it, some don't stop at all. But what we're going to do is we're going to imagine that we have an independent variable that is police officer. And the police officer is either present or not present. And then we're going to be observing what drivers do with these two conditions that we've created in the study. The dependent variables are the outcome variables of the study. The thing we will see some change happen, some difference, is based upon the influence of the independent variable. They need to be unambiguous as well defined, so they're not subjected to experimenters' biases. If we're talking about, I'm going to come to this study that just came up in just a moment. If we're talking about the police officer study in the balk line, we might be trying to see if people come to full stops or not, or if they stop short of the balk line like they're supposed to when the police officer are there in greater numbers than if the police officer is not there. So those would be dependent measures in the situation. There's a great study that a book I've used over the years is a classic in psychology. In 1959, Schachter studied anxiety of people, studying the concept of misery loves company. Participants were randomly assigned to hear one of two different descriptions about shocks that were going to be administered to them in a learning experiment. And this sounds an awful lot like Milgram, but it actually deviates strongly from Milgram. They never actually get into doing any shocking. They think they're going to do some shocking, but it's never going to happen. They're told either that the shocks are to be expected to be painful and intense, or they're told that they should be expected to enjoy the experiment and the shocks are more of a tickle or a tingle. Obviously, you know which one you would rather have told to you if you're getting ready to go with an experiment where there's some kind of electrical shocks that's going to be going on. So those expecting pain were expected to be and actually measured to be more anxious. This was confirmed through what's called a manipulation check measure, and your book talks about manipulation checks in some detail. Participants were then told to wait and given the choice of waiting either alone, with other participants, or no preference between these two. And persons' responses to that choice of how to wait was the outcome measure. That was the dependent variable. What they chose, what their choice was of those waiting conditions. The hypothesis was if people are made to feel more anxious, then they will be more often select to wait with others. And that is in fact what they found. Persons are generally more interested in waiting with others when they feel anxious about something. What do you think we should call the independent variable in this study, though? We manipulated persons with an electric shock statement, and we know that it was intended to manipulate their anxiety. What would you call it? Think for a few moments. There's any number of things that you might want to call it. We could just call it anxiety, okay? You could call it anxiety intervention, anxiety manipulation. You could call it a few other things that are related words, but if you're not touching on the concept of anxiety, then you're missing the point. If you named it something like electric shock, then you probably are missing the point. It wasn't that the electric shock was indeed was actually not ever going to be present at all. What was manipulated was what was described as the electric shock, how it was described to people. And so you're manipulating how people are likely to react to those descriptions. And then that has levels. I mean, you have a variable name, anxiety, but it has levels of high and low. Now, this is an important thing to note, high and low. It's not, the variable name is not high anxiety, and the variable name is not low anxiety. The variable name is high that has levels of, or excuse me, the variable name is anxiety that has levels of high or low. Another thing to note here is we don't ever label this independent variable no anxiety, because we can't ever really know that a person has zero anxiety. The mere fact that they're in some kind of study at all probably gives them some sense of anxiety. Here's another little study. On the next slide, I'm going to show two images. I'm going to show them fairly briefly, and I want you to choose which image that you find more appealing, the left image or the right image. They'll be coming up in a few moments. So which did you pick? The left image or the right image? And I have here write it down because I've done this in a classroom, but you can decide for yourself which one did you pick. Well, it turns out, of course, you may or may not have recognized that it's Audrey Hepburn, the great actress from the 1950s, and the one on the left, she has enlarged pupils, and the one on the right are the original image that I started from. Most people will tend to pick the image that's on the right. the one with enlarged, excuse me, the one on the left, the one with enlarged pupils. And the reason that people will tend to pick that image is larger pupils tend to be thought of as more attractive. Now, this mimics Hess's 1975 study. People with larger pupils will be judged more attractive. What's the image independent variable in this study? What do you think it is? Pupil size. How did we set it up? Well, I took an image and I photoshopped it so that one of them had larger pupils. It was set up to present them simultaneously, which we'll talk about later in part 2. What was the dependent variable? Your preference choice. Or we might ask you to give an attractiveness rating to both of the images, an attractiveness rating to the left image and an attractiveness rating to the right image. And either of those would be acceptable dependent variables. So there's any number of ways of measuring this kind of thing. Let's talk a little bit more about this because these are really critical features to make sure we understand well. Imagine that we've got a study in which instructors are asked to critically evaluate articles on Wikipedia, or the same article, but we say it's from a different source. Afterwards, we ask if they would to rate Wikipedia as a resource for learning about scholarly topics. Now, we all know that instructors, on average, have a negative attitude about Wikipedia. They tell you not to use it as a resource in your classes, etc., etc. Now, I'm not that way. I personally think Wikipedia is pretty good. It has to be used with caution. That's kind of true of every resource out there. A little bit of wisdom in looking at it is always valuable. There are two conditions in the study that the experiment has to set up. 2 levels. We have articles labeled from Wikipedia and the same article labeled from Encyclopedia Britannica. What would you name that independent variable? I'll give you a few moments to think about this as well. A good name for this could be source. The source could be Wikipedia. The source could be Encyclopedia Britannica. The 2 levels are Wikipedia, Encyclopedia Britannica, with source being the independent variable. There are other variable names. It could be something like text or information basis, or there's a few that label. It could be how the articles were labeled. Labeled Wikipedia, labeled Encyclopedia Britannica. Those all be reasonable. Source is probably, I think, best because that's really the core of what you're after. It could be used as a dependent variable. We could have a series of rating questions about reliability, validity, and trust of Wikipedia. All of those would work, and they would enable us to construct some kind of summation variable possibly. Of course, in all this discussion about variables, it boils down to something that we've discussed a good bit. Construct validity. Are we measuring what we think we're measuring? It applies to the creation of manipulations as well for an independent variable too. And we're always asking the question, is there good construct validity for the independent variable? In the Schachter study of anxiety, the behavior of the research assistant and their use of key phrasing to describe the electrical shocks created 2 conditions, high anxiety and low anxiety. And you may think, well, we're not actually manipulating anxiety. We're talking about the manipulation is phrasing, isn't it? Well, yeah, but we know what we're after. We're after a manipulation of anxiety, and by using a manipulation check procedure, we're able to see that yes, indeed, we did manipulate anxiety. And notice that again, as I said before, there's no anxiety condition because we cannot be sure that it's completely absent. In the Hess attractiveness study, the stimuli were identical except for the manipulated pupil size. So we have small pupils and large pupils. In fact, everything in his methods section of the original Hess study from the early 60s had sizes designated in millimeters, including pupil diameters after the retouching. They did not have the kinds of resources we do. They would use slide projectors, project them up on a screen, and they would actually measure them projected on the screen in a standard fashion. In our imagined study of professors' attitudes about Wikipedia, we need to carefully describe articles used and how they were presented to the professors and how they differed in the 2 conditions. Dependent variables are also carefully operationally defined so that we have good understanding of construct validity. And thinking about them is similar to the thinking about that for construct validity for surveys and correlational studies. So I'm kind of going to leave it up to you to read in the textbook about it, and it doesn't have a lot because it knows that you've read a lot about these things in the preceding chapters. For the Schachter study, they asked participants if they'd rather be alone with others or no preference, so the dependent variable was recording their response to the precise wording. For the Hess study of attractiveness, he asked which pictures people found more friendly or charming, words that are often associated with attraction. And the picture of the participants that was selected as more attractive was then the dependent variable, or that selection was the dependent variable. Participants tended to select the larger pupil image, suggesting that it is more attractive than the smaller pupil image. And this is the basis, by the way, of the ancient drug called belladonna, which is used currently as a medication used to make your pupils larger when you go to the eye doctor to have your eyes checked. But then the reason it's called belladonna is because it enlarges the pupil, is because was known from ancient times that this was a way to increase your attractiveness, to make you look more beautiful. It was used as a cosmetic aid by women, and belladonna, of course, means in Latin beautiful woman. And so what we're talking about is effectively something that's been known for generations, that larger pupils tends to make a person look more beautiful. For our study of the Wikipedia question about trustworthiness, we'd have to be careful about constructing our items, and if we are, we can maybe add up the responses to get a scale score, and we would call it the trustworthiness of the article. Whatever it did, we'd need to document it completely so others would understand and could replicate if they desired. All this construct validity is important. We have to lay our foundation well, but when we're talking about an experiment, internal validity is where the gold lies. That's where we're heading. The key benefit gained from doing an experiment is our ability to infer causal, not casual, make sure you get the spelling right, causal relationship between independent variable manipulation and the dependent variable that is measured. Three things need to be present to establish causation. Covariance. Can we measure a statistically significant degree of association between the independent variable and the dependent variable? Temporal precedence. Can we know that the independent variable manipulation occurred before the dependent variable was measured? This is usually very easily accomplished, so we don't spend much time worrying about it. And internal validity. Can we eliminate alternative explanations for the covariance we have documented? That's the key. Covariance, that's a statistical calculation that's very similar to what we were doing in our last chapter on measuring correlations. It's not that different. Internal validity, this is where we've got new ground to work on. Our biggest impact on internal validity is our ability to eliminate extraneous variables and confounding variables. So let's talk a little bit about what we mean by these two things. Extraneous variables are variables that are not controlled in the experiment and may have unsystematic influence on the dependent variable. That matters because it can reduce our ability to make strong statements about the causal connection. Some extraneous variables are called confounding variables, and that is because they systematically vary with the independent variable. The impact of the extraneous variable depends upon whether you've got systematic or unsystematic influence on the dependent variable. Confounding variables is much more important. It looks kind of like this. Imagine that we have an independent variable and we believe we've created a study where we can say it causes the changes we see in the dependent variable. Of course, there might be an extraneous variable out there. I think there often is. Now, if it's not systematic, then it does not, all it does is weaken our ability to state that there's a causal relationship. But if when we've created the independent variable, that extraneous variable is systematically varying with the independent variable, we call it confounding, and it greatly undermines our ability to make a causal inference. In fact, it practically eliminates it because we just don't know. We don't know whether our independent variable or the confounding variable really caused it. In part 2, we're going to be looking at selection effects and some other effects and how they specifically can have a big confounding effect in a study and how we deal with them by the design of the study. Thank you for listening to part 1, and I'll see you in part 2.